Hello, today we are going to take up a problem from IIT-JEE 1995 of topic atoms, standard 12 physics, and the question says something like this, that you have a neutral helium atom. So helium is actually 2He4. So if you draw its structure, then inside it you will be having 2 protons, 2 neutrons and 2 electrons surrounding it, like this. This would be the structure of the helium atom, right? So now I'm not going to focus more on the nucleus part, so I'll draw a simple nucleus like this, and here are 2 electrons, the first electron and second electron. Suppose both are moving like this, and since these are 2 electrons, they would be at a farthest distance away from each other, so diametrically opposite points, right? Okay, now we are supposed to remove these 2 electrons step by step. So if I am able to remove the first electron, how much amount of energy do I need to give? 24.6 eV, right? And it would be very easier for me to pull out the first electron, because this nucleus is attracting but this electron is repelling. So due to the repulsion, our job gets easier. We need not to provide so much amount of energy in order to pull this outside, because already there is a repulsion. Now if I remove the first electron, what is the situation? We have the nucleus, as well as we have only 1 electron left now, which is moving. So this will be He plus 1, and this would be now like hydrogen like atom. So now this is called as a hydrogen like atom because it has got only 1 orbit, and that too 1 electron in it, so they are called hydrogen like atoms. So we can apply the formula of energy. E is equal to minus 13.6 Z square upon N square. So if I substitute N is equal to 1, because this is the first orbit, and minus 13.6 into 4 upon 1, 2 square upon 1. So this answer turns out to be 54.4 eV. That means if I supply, that is negative, so the total energy of the electron in the first orbit of helium 1 ion, so the energy is minus 54.4 eV. So if I want to pull this electron outside, I need to give how much amount of binding energy? So binding energy is same energy but positive. So that means if I give this much amount of energy to this electron, its energy would become 0 and it would be out of the atom now, because it has 0 energy, or it will go to an infinite orbit. So that means we have already provided this amount of energy, and to the first electron, and to the second electron we have given this energy. So the total energy that we have given would be equal to 24.6 plus 54.4. So our total answer would be 79 eV. So the answer to this problem would be 79 eV.